Kavya, make your video off. Sound ತೆಗಿಯುವ ಸರ್ ತಕ್ಷಣ ಒಂದು sound ತೆಗಿಯುವ. Good afternoon, everybody. A warm welcome once again to our 3-day workshop, Demystifying R Programming. So today's third day session continued by our HOD sir. So please, all of you listen carefully and implement these commands in your laboratory and make a practice for that. And today's session will just start without any late, we will start with the session by our HOD sir, Dr. Murlidhar Gar. Sir, please continue, sir.
Yes, sir. Thank you so much for the introduction. Sir, am I audible, sir?
So yes, sir.
Okay. So, dear participants, good afternoon to one and all. I hope all you ready for today's session, and I hope you are all ready with your systems. And this day is the final day. I will try to cover all the topics as max as possible. So without any delay, let me share my screen and start the session. Right. So all of you open your R Studio. Yesterday we have covered some topics. We have covered vectors, all the basic operations on vectors, and also we have also seen some of the advanced operations. And up to this, you can see the highlighted topics on my screen. We have covered up to this, and for today's session I'm going to cover the remaining topics. For today's session there will be a list, data frames, as well as descriptive statistics. Let me try to cover as max as possible. So without any delay, let's start. So yesterday we have seen all the various operations on vectors, for example addition, subtractions, and also we have seen how to create vectors and how to modify the elements in the vector, single element at a time, multiple elements at a time. And also we have tried appending some data to the vector, existing vector. Also we have tried appending for the empty vector also. And let me start the session with this topic, logical index vector. So what is a logical index vector? So better let me explain you through an example. So if you see one example, then automatically you will came to know what is a logical index vector. See here, I am creating one vector named with S, which contains BB characters and CC characters. And now I am creating one more vector with the name L, and which contains true and true. That means these two are Boolean values, or we can call them as logical values. See here, S is a normal vector created with some elements, and L now is called as a logical vector. Why? Because the L contains Boolean values as elements. So now I'm saying L is called as a logical vector. And here I'm writing S of L. So what it means, when S is a vector and L is an element, this statement will print the Lth element of S vector. So now what is the Lth element? L contains two Boolean values. So let me execute this first, then we'll come to know how this Boolean values will work. So now I have created, see here, now I have created a S vector, and now I am creating the logical vector, and now I am trying to execute this statement, S of L. S of L. Are you okay? Are you got the point? I have created one general vector with the name S. I have created one logical vector with the name L, and now I am saying S of L. So let me execute this statement, S of L. See here, I got BBCC. That means same elements which are in the S vector are printed here. You may feel that what is unique here, what type of output we got. Just we have printed some elements in the S. This printing can also be possible without giving this L, without giving L also. If you print S automatically you get BB and CC. What's new in this? What is the need for keeping L here? And what is the need for creating a logical vector? And what is the need for saying S of L? What is new in this? So let me change the logical vector from true to false. From true to false. So now I'm saying false here. So see here, now the normal vector remains same, the elements BBCC, and now I have changed the value from true to false. That means I have changed the second value. The first value true remains as it is. Now let me execute these three statements again. See here, now I'm creating the general vector with the name yes. Now I'm creating the logical vector L. One is true, other one is false. Now I'm saying yes of L. So see the difference in the output. See here, in the previous time, whenever both elements are true and true, we got both the values, that means BB, CC in the vector. And whenever one element is true and one element is false, then I got the printout of only one element in the vector which has the corresponding true value. So by observing these two outputs, you can understand what is meant by logical vector. So a logical vector is going to define which values to be printed in the given original vector. So in the first example, I have given both true and true. So when you print S of elements of L, that means when I'm saying S of L means L contains true and true. So S of first element for the value true, S of second element for the value true, both are printed. Now when I'm saying only one true for the first element and the second is false for the second element, when I'm saying print S of L, only the element corresponding to true value, that is BB, is only printed. So with this, we can conclude that a logical vector is going to define which values to be printed from the original vector. So this is the purpose of the logical vector. I hope you all understand. Now, coming to the next one, called as numerical index. Numerical index. So generally, we have seen that whenever you create a vector in R programming, especially, the index starts from 1. But whenever you go to C, the index starts from 0. So in R programming, the index starts from 1. So see here, I will again try to explain you what is the numeric index with one example. See here, now I am creating one vector X with values AA, BB, CC, DD and EE. Let me create it first. So see here, the vector X is created and I am saying X of 3. That means I wanted to print the third value. Third value means AA is the first value, BB is the second value, and CC is the third value. So my expectation is when I say X of 3, the CC value will be printed. See here, the CC value is printed. So there is nothing new and unique in this. Just we have printed one particular element of the vector. Now, see here, now I am saying X of minus 2. This is somewhat peculiar. Why? Because whenever we use indexes, whether in C or R or anywhere, we have up to now we have seen all the indexes contains only positive numbers 0, 1, 2, 3, 4 or 1, 2, 3, 4 like that. All indexes will be in the positive mode. But now uniquely here I'm giving minus 2. First, let me try with only positive value. I'm saying X of 2, print X of 2. So whenever I said print positive 2, the second value, that is BB, is printed. Now give me the negative index. Negative index. So now let me see what happens. Negative index X of minus 2. There is no X of minus 2 in the vector because The index of AA is 1, BB is 2, CC is 3, DD is 4, and E is 5. But whenever you say X of minus 2, generally there is no index value with minus 2. But let's see what happens. See here, when I say X of minus 2, what results you got? A, CC, DD, E. See here, AA is the first index value, CC is the third index value, DD is the fourth index value, and EE is the fifth index value. That means all the elements except the second element are printed in the output. That means that whenever you use negative index, what are going to do is it will skip that particular index element and prints the remaining elements. For example, if I say X of minus 4, when I say X of minus 4, what is the fourth element? The fourth element in the vector is DD. That means except the fourth element, remaining elements will be printed. That means now I am saying X of minus 4. So what will be the output? The output will be AA, BB, CC, DD is excluded, and you get EE. Means AA, BB, DD, EE is the output. Is it right? No, I'm saying wrong. So please, that's why I'm asking you, please concentrate carefully. So whenever I'm saying X of 4, what is the fourth index value? That is DD. Except DD, the remaining values AA, BB, CC, and EE will be printed in the output. Let's check. See here, except the DD value, all the remaining elements in the vector are printed. So you need to understand that whenever you are using a negative index, then except that element, the remaining elements in the vector are going to be printed. So this is the flexibility with the negative indexing. I hope you all understand what is meant by negative indexing. Now, coming to the next topic, that is called as a duplicate index. So what is a duplicate index? Generally, indexes never be duplicate because there will be no index with double values. That means whenever you start your array or vector starts from 1, 2, 3, 4, 5. All these are index values and all are unique. And if in the C, if you start your array, the index starts from 0, 1, 2, 3, 4, 5, like that. Again, there will be no duplicate values. But here I'm saying duplicate index. Is it correct or is it possible? Let's try. So for this, I have created one vector with the name S, which contains AA, BB, CC, DD, and EE. So let me create this vector. Now I'm saying S of, for example, if I say S of 2, if I say S of 2, then you get the second element, that is BB. When you say S of 3, you get the third element CC. But here what I'm doing is I'm saying S of 2, 3, 3. C is for mixing all these values. Don't concentrate on C. C is for mixing all these three indexes, but concentrate that I'm trying to print S of 2 value, S of 3 value. Again, I'm saying 3. That means here the values are duplicated. The index 3 is duplicated. Now, let me try whether it will execute or it will give any error. No error, you got the output. That means that whenever you use multiple indexes, that means 2, 3, 4, 5, like that, or 2, 3, again duplicating the same index 3, 2, 3, 3, like that, the first S of 2 value, that is BB, is printed, and next the S of 3 value, that is CC, is printed. Again I am saying S of 3, so again it will print S of 3. So CC is printed multiple times, double times. So remember, in R we can use multiple indexes in a single statement to print multiple values, or we can also use duplicate values in indexes 3 comma 3 comma 3 or 4 4, like that. You can use duplicate indexes. How many times you mention that index, that index's value will be printed that much of times. So this is about the duplicating indexes. Next, coming to range indexes. See here, see the example. Here I am creating one more vector with the name yes. Now, generally I say s of 1 or s of 3 or s of 5, or just now we have seen s of 2 comma 3 comma 4 comma, like that will give. But here in the index, that means in the square brackets, I'm using two values, 1 is to 3 or 1 is to 5, which means that the values from index 1 to index 3. That means what is index 1? AA. What is index 2? That is BB. What is index 3? That is CC. Three values are going to be printed. That means we are mentioning in the range from which value to which value, from which index to which index, we need to print the values. So for this, I'm using some range 1 to 3. If you say 1 to 4, if you say 1 to 4, you get AA, BB, CC, DD. If you say 2 to 4, if you say 2 to 4, you get second value, that means BB, third value, and last value, that is DD. So you get BB, CC, DD. So like that, you will get values by mentioning the ranges of indexes. Now coming to some other one, out of order indexes. That means the given index is out of. That means, for example, we have 5 values, then the index contains 5 numbers. But now I'm saying out of order. That means if I say 7, or if I say 0, or if I say 9, then what happens? So here I'm giving yes of same. I'm taking this again same vector. I take the same vector for your example. Then I will say like this. If I say yes of 3 or if I say yes of 5, then definitely you will get the value because the given index is within the bound. Now I'm saying out of order. That means, for example, here when I say 6, but there are only 5 elements in the vector, so there will be 5 indexes. If what happens when I given an index which is out of s of 6, see here, you get a value called as NA. That means not available, or saying that there is no value for the index 6. That means the value is not available. Why? Because you have created a vector with only 5 elements, so there will be only 5 indexes. But if I give out of the index, then R simply reminds us that there is no value available in that particular given index. So like that, we can also try out of order indexes also. And next one, I'm saying named vector indexes. Or let me try with this example. So see here, imagine that you have the same vector, and now I'm saying 2 comma 1 comma 3. So whenever you give range like 2 comma 4, you get the value of the index increasing to the upper bound. Whenever you give 1 comma 3, then the value will be increasing to the lower bound. So like that, lower bound. BB has to be printed. Next, I came back to the first index. That means AA has to be printed. And again, I move forward to the third value. That means CC has to be printed. That means you need to know programming. There is no need to give indexes in an increasing order. You can in a zigzag fashion also. You can print the last members. So what is a named vector member? So let me explain you with an example. Now, have taken one vector which is equal to C of Hadoop, comma Spark. That means vector V is created with two elements. The first element is Hadoop, the second element is Spark. So I'm printing the vector V. See here, vector is printed. Now, so what I'm doing is, see, then we name the first member as first and member as second. That means now I want to give names to these members. I want to give the name of Hadoop as first, and I want to name the Spark as second. So for this, I am creating one more array with the C function, C of first, C of first comma second, and this array is assigned to one more array called this vector called as names of V. Now, when you execute this names vector, what happens is the first is assigned to Hadoop because Hadoop is the first element, and this element is assigned to Spark because Spark is the second element. Now, let me print the entire V vector. See here, we got some captions. First, second. First is Hadoop, second is Spark. So like that, whenever you want to print a table type of data, then you have to use the named vectors. That means we are going to name the values. I'm going to name the value Hadoop as the first one and the Spark as the second one. So like that, I'm giving names for the elements in the vector. Now, generally, see here, after coming to this, see here, whenever you want to print the first element, what you will do is, you will say V of 1. V of 1. See what happens? V of 1. See what happens? Hadoop will print it because Hadoop is the first element. Now, we can also access the elements of the vector with their names. Why? Because just now assigned the first name to the Hadoop and the second name to the Spark. That's why we can also call the elements with the index value of the vector, or we can also call the values of the vector by its names. So let me try with V of first. V of first. See here, you got Hadoop. When I say V of 1, you got Hadoop, and also we got Hadoop, which means that printing with index is common. Now in the second try, I printed the value Hadoop with its name. What is Hadoop name first? What is Spark name second? So I printed the Hadoop value with its name, like writing V of first. So you got the Hadoop. And when you say V of second, you get Spark. So like that, you can call the elements by using the names of the elements. Next, coming to handling missing data. So what is missing data? So for example, if you find if you take some table of students, which contains student number, that means register number, name, and fee paid, address, marks. When you take this type of data, there is no guarantee that all the rows and columns are filled with the data. Sometimes what happens is some data will be left over. That means some data will be unknowing. That means we are not able to know the data for that particular combination, and we kept it blank intentionally because we didn't know the value. What we need to do, just we left it blankly. So like that, whenever you have a data, no issue, and whenever data not available in a particular column and row combination, then that type of data is called as the missing data. Now the question is, If you want to process a table, is it correct to also process the table containing missing values, or you need to remove the missing values then process the table? So this is the question. Are you got the point? If a table contains missing data, that means some columns are kept empty because we doesn't know the data for that columns, then you can process the table with the missing values, or you can stop the process. So the answer is, whenever a table contains missing values, first step is find out what are the missing values, then decide the importance of the missing, then go further. So the very first step is we need to find the missing values in a given set of data. So let me see the first concept here, that is finding the missing value. So whenever you want to find the missing value in the R, you can use the function is.na. Is.na. So let me explain the functionality of is.na with an example. 3 here. I have created a vector x with the values na, means no value is available, that means empty value. So without keeping the column empty, I'm saying na. And the next value is 3, the next value is 4, and all the remaining 3 values are not known until now. So I kept not available value. So let me create a vector with some elements known and some elements unknown. See here what happens. Vector is created, vector is ready. Let me say is.na, in the brackets I am giving the name of the vector. So what you got? You got some logical answer. That means first I got true. True means that is for na. I got false, that is for 3. I got false, that is for 4. I got true, that is for na. Next I got true, that is for na. And next also I got true, that means for na. So which means that whenever the value is not present, that means whenever there is a missing value, the is.na function says yes, yes, there is a missing value and prints output. Whenever there is a value, is.na says that no, 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 value is readily available, so say false. So finally what you got is, when you apply the is.na on any vector, for the columns where the values are not present, for that column this function says true. True means yes, no value is available. And if the value is available, this function says false, which means that the value is readily available in that particular column. So like that we can use the is.na to find which location values are existing or which location values are not known, not available. So remember one thing, if any missing value is there, the function says that yes, and if there is no missing value, the function says that false. So like that we can use the is.na function. Now let me explain you the same type of other function called as is.nan. So what is the difference between is.na and is.nan? So let me explain with some other example. So here I'm creating a vector x, with the first value not available, third, fourth, fifth value not available, like that not available. This is no value and this is no value. So let me say first is.na of x. So what will happen when you say is.na x? See here, false. That means value is not available. And when I'm saying the 3, so 3s value is available. So see here, what is the difference between ease.na and ease.nan? See here, observe these two lines. Observe these two lines. The first output is for ease.na. And the second output is ease.nan. See here, the first output generated by ease.na function. One second. One second. I'm getting a call from the office. One second. So sorry for the interruption. So again, I'm explaining clearly. First, take the vector. First, take the vector. So vector is ready. Now I'm saying is dot na. So see here, vector is this one. This is the vector, and I got this result. That means not available value. Yes, it's saying true. Value is available, so it is saying false. Value is available, it is saying false. And whenever there is value is not available, it is saying true, 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 like that. Now let me execute is.nan. Is.nan. It is saying totally reverse. So see here, if value is not there, NA says it is true. If value is not there, NAN says it is false. That means almost NA and NAN are inverse of one another. So like that we can find the missing values. Then the question, the next point is, yes, we have missing values. Then what to do? We need to replace the missing values. The question is how to replace, what type of command we can use. See here, or before going to replace, at least we can remove them. If we are not able to replace, we can remove them. For example, see here, I have created one vector x with the values 1, 2, NA, 3, NA, and 4. So here two values are not available. The third index value and the fifth index value are not available. If you want to fill these values, you can say x of, I want to say x of x of, or I can say like this, x of 3, x of 3 is equal to, I can say some 3. So let me try like this, x of 3 is equal to 3, and let me print the vector. Let me print the vector. See here, I got what I got, x of 3. X of 3 is 3. So actually, this is the third position. Previously, the indexes are 1, 2, 3, 3, not available, 4. When I said x of 3 is equal to 3, that means I want to replace this third index value with the value 3, and you printed this. You got what you got. See here, NA 3, 3, NA, NA, NAN. That means here is the missing value. So if you try like this, if you want to notice the missing value, what you need to do is you try to remove the value. At least you try to remove the value. So for this, what I'm saying is I'm using the same NA function. And if it is not available value, then move the value called as D. Don't understand? No problem. Let me try with an example. So I'm taking a vector X and I'm saying D. So what is D? D is not X. And let me print the D. What you got? 1, 2, 3, 4. That means when you use is.NA, that means D stores, first D identifies what are the not available values. And whenever you say not D means print the values except the null values. That means print the values which are not available values. That means you get only the exact values and the not available values are excluded. So that is the way how you can remove the not available values. See here we have one more example. Whenever you say C of 1 comma 2 like this, and whenever you are saying x not a x, it gives that you have remove all these not available values and you get 1, 2, 3, 4 as the output. Next. Right. See here. Now filtering and subsetting. So how to filter or what mean by filter? So for example, I'm taking a vector with the values a, b, a, c, d, and I'm printing this vector. So you get the values. Now, what I'm writing here, see here, I'm writing is print or move the values to new vector with the name vector filter 1. Only those values which are not A and not C. That means I want to create a new vector with filter 1 name which contains, it not contains A and C. So let me try this. The vector is ready, A, B, A, C, D. Now I'm writing the not and I'm printing the new vector. So what you got? You got the output as AAC. That means the new vector is created with the values of the old vector, and those values should be either A or either C, which means that here in the old vector we have two A's, one C. So in the new vector you got two A's and one C, and the remaining values B and D are removed. So like that, you can use filter. Filter means whatever the values you want, that values only should come. And whatever the values you don't want, that value should be removed. So like this, what we can say is you need to say the vector name here and you need to use this percentage in percentage. Then you need to specify what are your filters. That means percentage in percentage means only pull the values which are A and C and left the remaining values. So we are removing something and we are pulling something which is called as a filtering. So like that you can also use filters. And subsetting. Subsetting means you have a vector with some elements and you want to print only some subset of your vector. So see here, I am creating one vector x with the range values, that means 1 to 15, which means that x vector contains 1, 2, 3, 4 like that up to 15. So create this vector, and if you print this vector, see here all the 15 values has came into the vector. Now what I'm saying, see here, I'm saying x 1 is to 5 only, x 1 is to 5. See, whenever I say x 1 is to 5, among all the values, whatever the first 5 values are only printed in the output. That means you can decide which values has to be printed and which has to be excluded, and that means you are extracting a subset of the elements from a big set of elements by using this range. or you can say, see here, I'm saying x of C1, 2, 3 like this, and let me execute this, what you will get. So without values present at indexes 1, 2, 3. So what you feel that when you say x of C1 to 3, you get the values in indexes 1 to 3. But see here, unfortunately, there is a minus here. So whenever minus is there, you need to exclude the values in the given 1, 2, 3 indexes. So in the final output, we got the values excluding the values of first index, second index, and third index. So like that, so you can work on vectors. So all these are different operations on vectors. And with this, we covered all the concepts of vectors. Now let us go into lists. Lists in R. Right. So now let us see operations on vectors is over. Now let us see lists. Right. Now let us know what is a list in R. So for this, so ask your chat GPT. Ask your chat GPT what is list in R. See here. So, and read these lines. In R, a list is a versatile and flexible data structure that can contain certain elements of different data types, including vectors, matrices, data frames, and even other lists. That means list is quite opposite to the vector, which means that vector only contains homogeneous elements, that means same type of elements, and whereas coming to the list contains different types, that means heterogeneous elements. A list contains any type of element. A list may contain vectors, a list may contain matrices, a list may contain data frames, a list may also contain one more list. But whereas coming to vectors, whatever the elements of the vectors should belong to the same data type. But here, when you take a list, the elements of list can be of different data types. So this is called as the list in R. So once again, I'm repeating, a vector contains elements of same type, and list contains the elements of different types. So this is about list in R. Now, let us try to create a list. How to create a list in R programming? See here, I'm saying employee ID is equal to C of 1, 2, 3, 4. That means here what I'm doing, I'm creating here not a list, here I'm creating a vector. See here, 1, 2, 3, 4. It looks like a normal vector. Okay, no problem. What you got? employee is equal to 1, 2, 3. Now, I am creating second one. You can say it as list or vector for some time. Now I'm creating one more vector or list with the name empl, which contains all the strings. Now I'm creating one more vector with the name number of employees, that is equal to 4. Right. Now we created 3 vectors. Let us fill their vectors. Now, see here, one is a double type of data, one is a string type of data, the other one is numerical value. when you have data belonging to multiple data types, if we want to combine all them into a single entity, then you have to use the list, because if you use the vectors, then these three different data types cannot be combined, because vector requires all elements of same type. But here elements are of different types. Some are doubles, some are numerics, integers, some are strings, characters, like that. So how to combine these three different types of data? And the solution is, the list is the solution. And how to create a list? A list can be created by using a list function. So in R, if you want to create a list, that means set of heterogeneous elements, that means set of elements of different data types, then you have to use an operation called as list. And in this list, see here, the first element emp id contains again 4 elements, and the element emp name contains some other elements, and the third element of emp list is number of employees. Like that, here I have taken one different type of vector. This is this is double, this is characters, and this is numericals, integers. That means data is are of different types, and I want to combine them into a single entity. So for this, I'm using a function called as list. And let me try this. And list is created. And let me print the empty list. See here, what you got? The first row, first column, 1 means the first row, first column will contains the EMP ID elements. That means what are the EMP elements? That is 1, 2, 3, 4. Next, the second row, first column contains employee names. That means this EMP name is temporary for DBI, Sandeep, Subham, and Sabita names. So like that, you can create a list with one set of numericals, other set of strings. Now take the third element, number of employees. This is a pure numerical integer value, and here this value appears in the third row, first column. So see here, list emp list contains, this is one type of data, and this is other type of data, and it is some other type of data. So there are three different types of data, but we are able to combine them into a single entity called as list. Called as list. So 1 second. A split waste for some time. Screen sharing point ना रह रही. So sorry for the technical difficulties. It will happen. So now again we are back. So let me share again. So let me share my screen again. Okay, I hope you are able to see my screen. So, so in the previous means in the previous command, we have created a list, that is EMP list, which contains the elements of three different data types, numericals, doubles, and strings. Now the list is ready, and try to access the elements of the list, like vectors. So here again, here employee list is ready, and now I'm saying print EMP list. So whenever I say print EMP list, you gives the output like this. But here, let me try it in a different way. See here, I'm saying employee ID. This is one element, and employee names. This is the other element, and number of employees. This is the next element. See here, and this statement is somewhat different. See here. Previously, also I created the list. See here. This is the list creation command. But this time the creation is somewhat different. See here, employee list. I'm saying employee ID is given the name ID, and employee names is given the name names, and number of employees is given the name as staff. That means even the elements of the list can have the names. Generally, list contains elements of different types, and here what I have done is I have renamed each and every member with some name. That means the employee ID member has given the name ID, the member EMP name has given the name names, and the member number of employees has given total staff. So let me create the list in this way, and now let me see what will happen when you get the output. See here, the output is somewhat different. That means previously you have got like this: one of one you got employee IDs, two of one you got employee names, three of one. Uh, are able to see my screen? Anyone? Anyone can respond, please. Are anyone able to see my screen? Please respond.
No, sir.
Or not able to see my screen. Okay, 1 second. Narayar sir Milchan sir. Narayar sir Milchan. స్క్రీన్ మళ్ళీ పోయింది. Just right. So once again, I'm sorry for the technical difficulties. So let me continue with the creation of list. So see here in the previous list creation, the list contains the row and column numbers, but see here now in the new list creation, we are able to name the rows. The first row is named as employee IDs, that means ID is the name. The second row name is names, and the third row name is total staff. So like that, you can also give names for the rows. So this is one way of this beautification of doing for the list, and try to access the elements of the list. Try to access the elements of the list now. Right. For this again, I'm creating an vector, first vector, and this will be the second vector, and this will be the third vector, and again I'm creating the employee list, and again I'm printing the empty list. So all these are common. Now see this command, see the highlighted command, print employee list of 2. That means I want to print the second member of the list. What is the second member? The first member is empid, which contains four employee numbers. The second member is employee name, which contains 4 employee names, and the third member is number of employees, one element. So whenever you print the second element, what the expected output is? The expected output is you need to print all the 4 employees names. Let us try whether we will get the expected output or not. See, so we got the 4 employee names. That means whenever I'm saying employee list of 2, the second element, that means the second member of list, which contains again 4 names, are printed. So if I say 1, if I say 1 here, then you need to print the employee IDs 1, 2, 3, 4. And if you say 3 here, you need to print the total number of employees, that is 4. So like that, we can print the individual elements of a list. Now, this is printing the entire member. That means if I say 2, all the names will come. If I say 1, all the 4 EMP IDs will come. But if we want to print a particular element, that means I want to print the employee names and only the second name has to be printed. That means only had to print the second employee name. So for this, you need to go one level deeper. The first level is the member index I had to give, and once I go into the member index, and again I had to give the index for that particular value. So for example, here I'm saying 2 of 2, which means that what is the second member? The second member is employee name, and in this second member I need to print only the second employee. Who is the second employee? The second employee is Sandeep. So only I need to print Sandeep. If I want to print Subham, then I need to give the values as 2 and 3, because employee names is the second member, so I have given 2, and Subham is the third index value, so I have to give 3 here. So like this, whenever you want to print a single particular value, you need to go one index deeper, next level. So let me try with employee list 2 comma 2. So what you got? You got Sandeep. And here I'm printing print employee list 1 of 4. So what is 1 of 4? What is 1 first? 1 is EMP ID. And in this EMP ID, who is the fourth element? Number 4 is the fourth element. So whenever I say EMP list 1 comma 4, you will get the 4 as the output. So like that, you can access individual elements in the list. You can access the entire member, or you can access individual list. ఏం సొంట్లో ఫోన్లు చేసి అమ్ముతున్నారు ఎవరు ఏదో PhD. Okay, sorry for the interruption. Now we have seen how to create the list, how to print the list, how to print the individual elements in the list. Now we'll try to modify the elements in the list. For this, again, let me create the list. This is the list creation, and I'm creating the list and I'm printing the list. So list is ready. Now I want to modify. See here, I want to modify the last element of the list. What is the last element of the list? That is total staff. Previously the value is 4. Now I want to make it 5. So how we can modify this value? So for this, you have to say the list name. The list name is EMP list. You have to use the dollar symbol. Then you have to use the member name. Then equal to, you have to give the new value. The previous value is 4. Now the present value is 5. So the 4 will be modified as to 5. See here. Now I have modified, and I will try to print the list again. I will try to print the list again. See here. Previously the value is 4. The value total staff value is 4. Now the total staff value is 5. That means we are able to modify the value 4 to 5. So like this, we can change the entire member value. And if we want to change the individual members, that means in a particular member, you want to change a particular inner value. So like that, what I need to do here. So here, see here, I'm changing, see this example, this particular example, you will get awareness of that. So employee list 2 of 5. Actually, previously there are only 4 number of employees. Now we have modified the total staff to 5. So I need to insert one more name. And for this, I'm saying employee list 2, that means employee names. In that 2 member, I'm going to add Kamala as the 5th member. So when you execute this, the employee names will be updated and Kamala is added. And if you print the list again, see here, previously there are 4 names and now we got the 5th name. Like that, you can also modify, for example, employee ID 1, and in the 5 you can say D5. So now for Kamala we have given the employee ID as 5, and if you print the list, you can get the new member inserted. That means previously there are 4 employees with 4 names. Now we have the 5th employee with the name Kamala, and the total staff count is also modified to 5. So like that, we can create list. And so now let us concatenate 2 lists. Let us concatenate 2 lists. So how to concatenate 2 lists? So concatenation is very simple in R, and let me show you with one example. And let me first create the list 1. So this is the creation of list 1, and I'm printing the list 1. I'm printing the list 1. So list 1 is ready with employee IDs, employee names, and total staff. And now I'm creating a new list. So now I'm trying to create a new list. The new list name is employee age list. Employee age list. So we have 4 employees. So I have given here 4 ages. First employee age is 34, second employee age is 23, third employee age is 18, and fourth employee age is 45. So I'm created the second list. Now 2 lists are ready. 2 lists are ready. So now try to concatenate, mix these 2 lists. So see here, it is very simple. We can use just the C function. C function is enough whenever you want to merge or concatenate these two lists. Thus, I'm saying C in the brackets, the name of the first list and the name of the second list. See here, now the lists are concatenated to one another, and finally I'm printing the final concatenated list. See here, the first row contains the numbers, the second row contains the names, the third row contains the total staff count, and the fourth row contains the employee ages. Previously, employee ID, employee name, total of staff count is in the one list. All the employee ages are in the second list. Now we have merged these two lists into a single list by only using a simple C function. That means concatenate function. So this is the flexibility given by the R programming. But whenever if you want to concatenate any two arrays or any two files or any two elements in the C, you need to write a big programming. You need to write a huge lines of code. But with a single command, you can concatenate two lists. So this is the beautifulness of R programming. Next, coming to deletion of the list. That means now we have created the list, we have modified, we have concatenated, and the next one try to delete the elements of the list. For this, let me again to create a new list. So this is the list creation process. Already you know how to create a list. That's why I'm going somewhat in speed. So this is okay. Now I'm going to print the list. See here, now my list is ready. Same list we are seeing from the starting. Employee IDs, employee names, and total staff count. And let me delete. So how to delete a particular element? See here, when I say this command, see, observe this command clearly. I'm saying print employee list of 3. So when you execute this command, what happens? The third element of the list will be printed because I have given the third element index here. But when I'm saying -3, that means negative index. Already you know what is a negative index in the vectors. If we give a negative index, except that particular index value, all the other remaining will be printed. The same logic I'm applying here, and here I'm giving -3. So let me try what you get. See here, the list is printed again, excluding the third element. That means from the list, the third element is deleted and the remaining two elements are printed. In this way, we can delete any particular element. For example, here, first print the list. Again, I'm doing some other logic. Print the list, and now I'm saying -2. What will happen? The second member of the list will be deleted. That means employee names will be deleted, employee IDs and total staff count only will be printed. See here, only employee IDs and total staff count is only printed. So like this, you can remove any member of the list from the output. But remember, this is not a permanent deletion. This is only a temporary deletion. And coming to the next level, that means I want to delete a particular value in a particular member of the list. See here, for example, I want to delete Sandeep. Sandeep is the second employee in the second member of the list. What is second member? Employee names. So I want to delete Sandeep value from employee names. So employee names is the second member. So I'm writing 2 here, and Sandeep is the second value in the second member. So I'm saying -2. So I want to delete this particular Sandeep. So in the second index, I'm saying -2. And let me try with this. So see here, you got the list, deleted the Sandeep name from the employee names. So like this, you can also delete one level lower. So with this, I conclude the operations on list. So now let us go to next topic, that is data frames. So now let us go to ChatGPT and ask ChatGPT what is a data frame. So I'm asking ChatGPT like what is a data frame in R? See here. In R, a data frame is a two-dimensional tabular data structure that can store different types of data in its columns. So simply we can say like a table of values. So simply you can feel that a data frame is a table of values, like your Excel file. So as all of us know that Excel contains a set of rows and columns. So a data frame is almost like an Excel file, or you can imagine like your relational database, which contains multiple tables, student table, employee table, like that. So in R, the same table is called as a data frame. So now we are working with the tabular type of data. Since R is a very well-known programming language to work with data, that means with R, we are able to perform different types of data analytics in a very flexible and simple way. So let me explain some basic details on the working of R for data frames. Right. See here. See, what is a data frame in R? So data frame in R are generic data objects of R which are used to store the tabular data. Just now I said this. Data frames can also be interpreted as matrices. That means since it is a table, you can feel it as a two-dimensional matrix. And each column contains different data type values. Because if you take a student table contains, for example, let us imagine that contains three columns. One column says student IDs, which are numericals. Second column says student numbers, which are some strings or characters. And third column is, for example, your percentages or averages, which is some float or double values, like that. A table contains elements or data of different types. So now we can find the similarity between a list and the data frame. As we know, a list contains elements from different data types. Data frame also contains elements from different data types. But here, whenever you say data frame, this data frame has a defined structure, that is set of rows and columns, and list is also has defined structure, but this structure is unclear. And the second difference between list and data frame is lists are used to store very small amount of or minimum amount of data, that means minimum amount of tabular data, and whereas coming to data frames, it stores huge amount of tabular data. So whenever you want to work with large amounts of data with R programming, first you need to store the data in the form of a data frame. Then you can perform different data analytics on the data frames through R programming. Right. Now let us go with these data frames. First we go how to create a data frame. See here, I'm taking this code. Observe this code which is highlighted on my screen. So I'm creating a data frame. That's why here I'm saying data dot frame, and within the brackets I'm saying friend IDs, which means that I'm creating my friend database. and this friend database contains my friend names, and also I have given each friend one ID. So here what I'm saying, first I'm writing the friend names. So all these are my friends, and for each friend I'm giving one friend ID. So like this, for friend ID I'm saying 1:5. That means the friend IDs will be in the range of 1, 2, 3, 4, 5, and the next element I'm saying friend names, and just I'm mentioning the names in the string format. See here, the second elements are strings and the first elements are numericals. So data frame is a combination of elements of different type. Now let me create the frame like this. So now I'm printing this friend data frame. See here. Now you can find a difference in the output of list and the output of data frame. So in the output of list, as you have seen here, see here, I'm showing one previous output from the list. See here, even though it is saying first column, I will show one more output which is more understandable to you. See here, this is the output when I created my first list. See here, see, even though it is saying first row, first column, and it is saying here second row, first column, and I'm saying here it is third row, first column, but there is no structure involved in the output. But the values are clearly defined. These values belong to first row, first column. These values belongs to second row, first column. This value belongs to third row, first column. But the structure is not clearly defined in the list. But whenever you are coming to data frames, see here, you can find the difference in the output itself. The structure is very clearly defined. So friend IDs are 1, 2, 3, 4, 5, and friend name are Sachin Saurabh, like this. So data frame list are almost same because both contains different types of data elements. But whenever talking about the structure of the data, that means how the data is organized, list is just organized data. But whenever you are coming to data frames, it is a well structured data, because here you can find a tabular structure for the data frame values. Now let me try some other operations on data frames. See, get the structure of the data frame. So already I said that data frame is a well structured data. So now try to use this command. See here, print structure of friend.data. Let's try what you'll get. What is meant by structure? See here. So when I wanted the R to print the structure of my data frame friend data, it says that the first column values 1, 2, 3, 4, 5 are integers. See here, it is saying integers 1, 2, 3, 4, 5. And the second column values, Sachin Saurabh, like this, it is saying that these are characters. That means the structure is going to tell us the data type of each element of the data frame. So here, whenever I try to print the structure, I got the structure and came to know that the first data frame element is of type integer, and the second data frame element is of type character. So like that, you can also find the data types of each element of the data frame. Now, sometimes you have a huge data frame which contains huge number of data, but you don't want all the values. Sometimes you want summary. That means how many friends are there for me, because I started writing my friends names in a database, and I'm continually updating or appending the names. At one moment of time, I want to find how many friends are there for me in my database. So like this, sometimes we require some summary of the data. So in R, this summary can be calculated in a very easy manner. So now I will show you how we can calculate these summaries. So here again we have a same friend data frame is created, and friend data frame is, let me print the friend data frame. So friend data frame is printed here. See, now I will show how to get the summaries. See here, I'm saying print summary of friend data. So I want the summary of my entire friend database. Let me try with this command and know what it will give. See here, it has given some statistics. See here, and observe it clearly. So for the first column friend ID, it is saying that minimum value is 1 and maximum value is 5. And the first quarter is 2 and median is 3. Mean is also 3. Third quarter is 4 and the max value is 5. That means the total 5 values are divided into different clusters, and the middle cluster contains the value 3. The above third value is 4. The below third value is 2. And the minimum value is 1 and the maximum value is 5. And whereas coming to the friends names, the friend names all are characters, and the average length is 5. So that's why it is giving the length as 5. So like this, it gives some summary of the entire database. So by seeing this, I can feel that whenever the maximum value is 5, I can feel that okay, I have 5 friends in my database. Whenever the maximum value is 20, when I get the maximum value is 20, you can know that okay, 20 friend names are there in my database. Like that, we can find some statistics from the data frames. Now, let us try to extract the data from a given data frame. We have a data frame readily available with some good amount of data, and I want to extract some required data from the data frame. So let me try with this, and again here I'm creating one data frame, the same data frame I created, and see here I'm creating one more data frame result, and this result data frame is created by using friend.data, that means the data frame $symbol friend name. So what it means, I'm saying the friend name. What is friend name? Friend name is one member name in the data frame, and friend data is the name of the data frame. That means this looks like an array name. Friend.data is an array and friend name is an index. For example, S of 4 means S array 4th element. The same way, data frame name, data member name. So let me try with the output and see here what you will get. You will get only names. So this command is exactly looks like, for example, S of 2. S of 2. Imagine S is an array which contains some elements, and now I want to print only the second element. So you need to say S of 2, only the second element is printed. In the same manner, here my friend.data frame contains 2 elements. One is friend ID, the other one is friend name, and I want to print only the second element, that means friend name. That's why I have given the member name here. The member name is friend name, and the output is only that values. For example, here whenever I say here friend ID, only IDs will come. For example, data frame contains some other data. If we give the name of the data, only that data will come. So we are extracting whatever the data we require from the huge number of data available in the data frame. So this way we can extract the data from a given data frame. Now, expand. So what is meant by expand? That means you want to add more data. So data frame is there, some data frame is there with some default data, and now you want to populate your data frame with more amounts of data. You want to add. So how to add? So for this, let me again create the data frame. And see here, in the data frame, we have two members. One is the friend IDs and the other one is friend names. Now, I want to add the addresses of these friends. That means I want to add the location, the city name. For example, feel that it is city name. What is the city name of Sachin? What is the city name of Saurabh? Like that, I want to add the city names or I want to add addresses of my friends. For that, I need to add one more column because basically now the data frame contains only two columns. So whenever you want to add the addresses, which means that you need to add one more column for the existing data frame. And for this, see here what I'm doing is, so friend.data is my data frame name, and I'm using the dollar symbol, and I'm naming the third column name as location. And for this third column location, I'm specifying the 5 location values, which means that for Sachin, I want to give Kolkata. For Saurabh, I want to give Delhi. For Dravid, I want to give Bangalore. Like that, I want to add the location names for the existing data. So now I have added, and let me print the friend data. Let me print the friend data. See here, you can see one more column is added. That is the location column with the values just now we mentioned. So like this, we can extend the existing data frame with the more data populated into the data frame. So this is one. And now here we have seen adding extra column. Now let me show you how to add extra row. That means I want to add the 6th row. I want to add the 7th row. That means I want to extend the data frame row basis, row by row. So let me show you how to add these rows. For this, again, I'm creating some data frame. So I'm bored with the values of Sachin and Saurabh. That's why I'm giving some new data frame here with the new values. See here, name, language, age. This something names, some random names. Name is Amiya, Raj, Ashish, and languages are or Python, Java. Age 22, 25, 45, like that. Now, imagine I want to add one more row. For this, this is the command. So what we have to do is, we have to add a new data frame, because you want to add, if you want to add one row, which means internally that you need to add 3 columns data. So for this, what I'm saying is, first I'm saying the data name. This is the name, column name with the value. Next, column name with the value, and next column name with the value, which means that now I want to add a new row with Sandeep name, language as C language, and age as 23. So for this, first I have mentioned the values, newly wanted values to add to the data frame, and to which data frame we want to add, that is df. So I'm saying df comma and bind. I'm saying bind. I'm using the function called as row bind, or bind means row bind. And this whole data frame with 3 rows is added a new row with these values, and a new data frame, new df is created, and this new df will contains the 4 rows values. So now up to this we have executed. Now let me add a new row. So new row is added, and print the newly added row data frame. See here, previously the last row is Ashish, now Now one more row is added to this existing data frame. The new row is this one, Sandeep C23. So like that, for the existing data frame, we can add both the column names and also the row names. Next. So already we have seen some adding extra columns. Editing. Let me go to edit. Edit means you want to change some values. For example, I have given this 45 or this 25 or this 22 wrong values. I want to change them. Yes, I can change. See here, let me work with this example. Again, I'm creating a new data frame and here I'm printing the data frame. Now, see here, what I'm saying is df 3 comma 3 is equal to 30. So what is 3 comma 3? So 3 is first 3, as you know, in a double dimension array. Already in the starting I said that we can also imagine a data frame as a double dimensional array which contains a set of rows and columns, because here data frame is also a table. Table means set of rows and columns. A table can also be a double dimensional matrix which also a set of rows and columns. So finally, when you say the first 3, it means it is the third row, that means the Ashish row. And whenever I say 3, the second 3, it means the third column. That means you want to change this 45 to 30. I want to change the value of 45 to 30. For this, I am writing like this: df, that means the data frame name, 3 comma 3. That means third row, third column value should be updated with 30. Now I have done this updation, and let me print the new updated data frame. See here, previously the Ashish age is 45. Now the Ashish age is updated to 30. So like that, we can also perform the editings, updations of the existing data frame. Now, this is one way of editing, and there is some other way of editing the data frames with the help of edit command. We have a predefined command available in R called as edit, and with this edit we can also edit the data frame. So let me try with some examples. See here, I'm creating one data frame, my table, and I'm saying my table is equal to edit my table. See here, do you got what I'm doing? I'm doing it again. See here, I'm creating new data frame with the name as my table. See here, my table, and I'm saying edit my table. See here, a new table is created itself. So you got a new table here. See here, you got a new table here, and you can type whatever the data you want here. You can type whatever the data you want, and once you type and just say nothing is there, just close. Once you close, then you can print. Okay, see here how simple is this in creating a table of data in the R. So I'm doing it again. Table, I'm creating the data frame, and data frame I'm allowing this data frame for editing. So see here again, one I can name as Sachin, I can name as some 30 something, 50, like this. And here I can give 2, I can say Dravid, I can say some 34, I can say some 12, like this. I can give some values and close it. After closing it and coming back and try to print my table. See here, whatever the values I have given in the table are stored in the data frame directly. And now let me edit it again. See here, the data is already stored, and if you want to edit, you can edit. 23, 12 has changed to 23. Close it and print it. See here, the 12 is changed to 23. See how simple is this? creating a table of data, modifying whatever the value you want, whatever the type of value you want. You doesn't bother here. Just open it, modify it, save it, print it. So that the beautifulness of R, and this much of flexibility is given by the R. Sometimes you can find that in some concepts R is more flexible compared to Python. And now coming to the deletion of rows and columns. So how to delete the rows and columns? For this, again I'm creating a new data frame. So printing the data frame, and see here the same logic, that is -3 -2. Minus means remove. Remove the third row second value. Third row second value means delete the Ashish rows second column is Java. So this I want to delete the Java and print the new df. See here, Ashish Java 45 is gone. So like this you can also delete. So like this you can apply some deleting operations on data frames. So this is about all the data frame operations we have seen here right now, and now it is almost 3:20. So one more topic is pending, that is called as descriptive statistics. So I will show you some of the operations here, and later I will share the other functions to you. So let me start. Import your data into R. So let me show you. Right, see here. So descriptive statistics means you want to work with more amount of data. So data frame also contains huge amount of data, but whenever this huge amount of data, you want to perform some statistical operations. And this, fortunately, this R provides huge number of statistic operations for performing huge number of computations in a very simple manner. For this descriptive statistics, see here one beautiful command I will show you. Thanks for. So see here, one beautiful command I will show all of you. You can take one Excel file. You can take one Excel file from MS Office, store the data in the Excel file, and you can pull the Excel file into this R environment. So that simple is that with R. Like Python, here also, maybe I hope that you all remember the Python concepts of extracting the data from the data frames. Here also, open one Excel file, a new Excel file, fill the Excel file with some data, and you can pull the file to the R environment. So for this, here, see here, I'm using this command. My data is read the file. See here, I'm just see here what happened. Just see again. I'm pressing this command. See here, it is opening some window, and from this window I can select any Excel file, and once you select the Excel file, it automatically pulls the Excel file into the R environment. So let me pull one Excel file. I have prepared one default Excel file for the demo purpose. See here, there is one Excel file called as sample. So this is prepared for your demo purpose, and this sample Excel file contains some data. Now I'm selecting this sample Excel file, which means that this sample Excel file is now pulled into the R environment, right? And now let me read the data from the file. Read the data from the file. I will do this again. So now I have pulled the data and I'm going to print the data. See here, and I will show the Excel file also. So this is the sample Excel file I'm showing you, which is a normal MS Office Excel file. See this is a normal Excel MS Office Excel file, and from this Excel file I pull the data and include in the R environment. See, the total Excel file is dumped here. The total Excel file, whatever the data has shown right now in the Excel file, the total Excel data is dumped into the R environment. So like this, you can pull any Excel file or CSV file into your own environment. Now, let me explain you some built-in functions on this descriptive statistics. See here, I want to print the first 6 rows. This table contains many rows, no doubt, but I want to print only the first 6 rows. See here, what I said? I said head, my data, comma 6. That means head means from the top. From the top, print only 6 rows. So like this, we can print whatever the amount of data you want with the using the function head. That means starting from the top, you can get 6. If you say 10, you get 10 rows. You can say 4, you get 4 rows. So like this. And I show you some other functions. So what is the mean? You can also find the mean of the values of your data set. There is some syntax error. Okay, no issue. See here, you can also try to measure the variability. Maybe these functions are not working because this or today is a trial version. So there may be some functions will not be working here. So you can also work with quantile and variance, standard deviations like Python. I hope you remember this, finding the variations and standard deviations, medians, mode. So like that, we can find the different statistical values from the given data set. So for this, you need to remember only one thing. The one thing is, first you need to extract. You need to extract the data from the Excel file or the CSE file. Once you extract the data, you are able to perform any type of statistical functions. There are huge number of statistical built-in functions available in the R. So for further reading, I will provide you some websites. So I have gathered some websites for further learning of descriptive statistics. So all these are different websites from GitHub or some other standard websites. So I will share with you later all these URLs personally in your groups. And it is almost 3:30, and now I want to end this session. And before going to end this session, I allow some of the students to ask any queries one by one, not creating the disturbance for the program. If anyone having any doubts, you can ask online. And after this session, you will be shared with two feedbacks. You'll be shared with two feedbacks. One is day third feedback, and the other one is final feedback. So because this is the third day, so we have a third day feedback form is separate, and the entire FD workshop feedback form is separate. So please remember, you need to fill the two feedback forms, and also remember that those who have attended all the 3 days workshop in the college, not from anywhere, in the college, and who have full 3 days of attendance filled with 4 feedback forms will only issue the certificates of the R programming workshop. And if anyone is absent for at least one day, also we are not going to provide the workshop, because already we said that attendance is very mandatory. And so with this, I conclude my session, and I'm open for Q&As. If anyone is there who is interested to pose your questions, yes, I'm ready. And if there are no questions from the student side, I will ask my faculty Pani sir to conclude the session by a simple vote of thanks. So if anyone has any questions, please pose the questions, or we'll conclude with the final note of Pani sir. Students, I expect at least some questions. I request the student to raise your hands if anyone is having any queries. Only the students who have raised their hands, only those students will be unmuted. Puneet.
Can you please explain me regarding how we use filters in lists, or more specifically in vectors?
Yes,
Hello.
already we have seen using filters, right? Already the session is covered with the filters.
Yes. Yes. It's just that when you wrote that program, it's a bit confusing for me. Where exactly are we going to use specifically this
Okay, no
percentile,
issue, Puneet.
in and
You can meet
percentile?
me personally. You can meet me personally. I will clear your doubts.
Okay, sir.
Okay,
That's
already I
it.
covered the filters, using the filters. You have more, if you want more clarifications, you can meet me personally. Okay.
Okay, sir. Okay. Thank you, sir.
Yeah. So anyone?
Any other queries? Any other queries?
Naraz Almesh.
Any students can ask queries fast.
So, have any queries?
Okay. So any queries? Okay, sir. Thank you, Murli sir, to continuing long session today from 1:30 to 3:30.
One second, sir. One second. I request all the students to stay in the classroom itself. I'm coming to see you personally. If anyone is not there, I will take the attendance and I will take the snapshot also. So I request all the students to not move from the classrooms. Now I'm coming to your classrooms and I will see you. If anyone is not there, definitely I will take the pics.
So all the students stay back in your classrooms. I I'd like to give thanks to our Murli sir, our HOD sir. A long session, 2 days. He made so much explanation about R. I think all of you understand all these things. And thank you very much, sir. And we are and you need to fill your feedback forms. We are already shared. Thank you.